Well, good morning, everybody, and welcome to Ellensburg, Washington, USA. It's late morning on Thursday, November 30th, 2023. Thanks for joining us this morning. There's light snow falling, although most of it has melted on the pavement so far today. Thank you for joining us. It's been more than a week since we've done this, so it's so great to see more than 250 of you here. Here's to you for joining us this morning. The local time is 11:48 a.m. And if you're watching this in replay, you can go ahead and scrub ahead 12 minutes. 12 minutes to the top of the hour in replay will get you to the beginning of the quote-unquote program. 2023. But many of you know the drill. If you're watching live, I like to say hi to folks, make sure that we're doing okay. I already see the 5x5, so that's terrific to see. Where are you viewing from? Boone, North Carolina, Portland, Oregon, South Florida, Vancouver, Washington, Coulees, Texas, Omak, Washington, Minneapolis, Minnesota, Half Moon Bay, California, Lacau, Finland, Fairbanks, Alaska. Fort Collins, Colorado. I'm just trying to grab these things as they go by. Boulder, Colorado. No, I can't do that. It's too fast. It's too fast, everybody. Langford, UK. I'm back a ways. Amsterdam, the Netherlands. That's Arhan. Spokane Valley, Washington. Nina from Norway. Vienna, Austria. Boulder, Colorado. The Dells, Oregon. Let me come down to live now. Things are a little more manageable. Budapest. Centralia, Washington, atop the Rattlesnake Tuff. I guess that's in Oregon. Havre, Montana. Hobart, Australia. Leuven, Belgium. Degeldorf, Germany. Hello. Waikele, Hawaii. Brisbane, Australia. Another good one. Gary Paul is in the bottom of former Glacial Lake Sauk. Oh, now you're just showing off, Gary. Kamloops, BC, Alloy, Arizona, Klamath Falls, Oregon. If you're confused and you're watching this in the replay, thank you for tuning into this. I'm glad you found the program. These are live streams. There's a bunch of people here live, and we will begin the program in about 10 minutes. So if you're watching this in replay, you can fast forward or even just click on the chapter title that says beginning of the program or something like that. Puyallup is here, everybody. Asheville, North Carolina, Dorset, UK, San Diego. 500 people watching now live. San Diego, California, Indianapolis, Indiana, Bonaire, Dutch Caribbean. That's Andre. Yeah, more exotic locations if I missed you. I'm getting greedy now. The Midlands, UK, Dorset, UK, Billings, Montana. Exotic. Paris, Illinois. Craig from the Methow. Deering, Kansas, where it's 54 degrees. Nice job, Daryl. Forest Grove, Oregon. Papageno, on my couch, uppercase. Hello, San Diego. All right, I got one tip before we begin. Some of you remember, if you've been watching for a long time, back to when I was live streaming Geology 101 with the masks and everything. Like that was winter quarter 2021, I think. And there was a kid in there, a freshman named Bryce. And then Bryce, as a freshman, not only sat in on the 101, but then took Geology 351. Bryce the Rock Licker. Well, Bryce the Rock Licker has a message for you. I asked him to actually just come in and talk to you directly, but he's too shy. So he goes to the overhead camera. Yeah, you know the drill by now. It's Thursdays at noon and Sundays at 9 a.m. But so this is not worth I don't think, driving 2 hours each way. I don't think. But if you're within a 60-mile radius of Ellensburg, I guess, there is an event right now, tomorrow and Saturday, and that event is called the Ware Fair. It's almost the 50th anniversary of the Ware Fair, which happens in the Student Union building here at CWU. It's an arts and crafts festival. And the Ware Fair this year is today. It started at 10 this morning. It's going until 7 p.m. Tomorrow, Friday, December 1st, 10 to 7, and Saturday, 10 to 3. And Santa and Mrs. Claus will be there. The Geology Club has a table. Bryce the Rock Licker is the CWU Geology Club president. And every weekend, Bryce the Rock Licker is in the rock saw room cutting rocks, polishing rocks to be sold as a fundraiser for the club. So there's a Geology Club table selling rocks, I guess. I don't even know. I was going to go over there and check them out, and I forgot to do it before we started here. But it's a full arts and crafts, Christmassy, holiday-ish kind of arts and crafts. What can I say? I'm not good with candles and jewelry. And you can support the Geology Club if you want to come over today, tomorrow, or Saturday. One more time, that's Ware Fair at the Student Union building at Central Washington University. Bryce the Rock Licker will not be taking all shifts, but he'll be over there most of the time. I should have done my homework. I don't know what they're selling. So anyway, there you go. Couple more hellos. Looks like we're functional. Actually, can I double check that the stations are working? That's the desktop. That's the document camera. That's the shelf cam. There's a little bit of light snow now. Possibly you can see it. And the corner cam. I'm liking those cameras. Yeah, 5x5 for everything. Good. Couple more hellos, and then I need to start thinking about what we're doing today. Today will be loose. I have some loose plans. I'm already kind of half worn out. I taught at 10 o'clock this morning. And it was a good session, but they took a lot out of me. That's the wrong way to say it. There was a lot of good energy, and we were bouncing ideas back and forth. So I need to find my second wind here. Thurston's in Notre Dame. Shake Down the Thunder. That's South Bend, Indiana. Tamara is in East Tennessee. Fall City, Washington. Orangevale, California. Göteborg, Sweden. Maple Valley, Washington. Jerome Lessman in the His Eight. Hello, Jerome. Beaverton, Oregon. Rogue Valley, Oregon. Marysville, Washington. Avaiano, Italy. Hello, Jim. Orem, Utah. Elaine says that Adele is checking in from New Zealand. Okay, well, thank you. Omaha, Nebraska. Jerome Lessman's in the His A. Thorpe, Wisconsin. Edmonds, Washington. Hey, Peter, I keep saying Yush. What do I say, Peter? Can you help me pronounce your Swedish town? It looks like Linkoping, but I know the umlaut means something else. I'm just curious. Because you're a regular, Peter, and I hate butchering it every time. What do I think I say? Yushaping. I don't doubt that's right. Garrett, the Dutch Night Owl from the Netherlands, says it's -1 Celsius in Laren, Gelderland, the Netherlands. Okay. Yeah, we're doing okay. I got 3 minutes. Costa Mesa, California. I'm going to hang on for Peter for just a second. A little pronunciation guide. And David's chiming in, but he's not sure. Ling Shopping. Peter's like, what do you want? I can't help you. Talking about Backcountry Gary's calendars. Okay, I got to concentrate. All right. Peter says I'll look it up for the next session. Okay. All right. Okay. Live chat is there. Give me just a second. We got more than 600. shrink this window. I don't want to shrink that window. I want the live chat right in there, but I need to be able to see home base. Yep, that's how we're doing it. Okay, I need to go take a walk around the building and get my head right. Thank you. I will join you in 2 minutes. Hot mic. Hot mic.
How do I? Is there a way I can pick up regular high school class?
A pleasant good afternoon to you all, and welcome to Ellensburg, Washington, USA. I'm speaking to you live from a geology faculty office on the first floor of Discovery Hall. I'm your host, Ned Zentner. And today's episode, session E, is entitled Pre-Glacial Drainages. Now, how about that for clickbait, right? Everybody's going to be clicking on that. What's that? Pre-Glacial Drainages. Give me some of that. Of course not. Nobody knows what that title means. I barely know what that title means. So I need to explain what the title means. Is it really like what it sounds? Pre-glacial, before the Ice Age? Yeah. And you're like, you got to be kidding me. This is you talking. I signed up for Ice Age Floods A to Z, and this is the 5th show, and we're still not in the Ice Age? That's right. That's me. That's right. We're not going to be there on Sunday either. I like a question that I've stumbled onto in the last Well, since I saw you last, and we've been away for more than a week because of Thanksgiving holiday. I hope those that celebrated that enjoyed their time with their family and friends. I did too, but I was also thinking about what am I going to do for E and F? And I came up with this question, and the more I think about the question, the more I like it. It's pre-ice age, it's pre-glacial, and it involves drainages, rivers, streams, babbling brooks. And you're like, why is that an interesting question? Okay, well, let me give you the question. I'll let you decide if you think it's interesting. Question. What did Eastern Washington look like 2.6 million years ago? That's the question. What's the visual? What did Eastern Washington, from Ellensburg over to Idaho, from the Oregon state line all the way up to Grand Coulee Dam, how close can we get to a very specific visual for what that landscape looked like? And you're like, why 2.6 million years ago? Well, that's the beginning of the Ice Age. That's when we're turning the thermostat down. And that's when the ice starts approaching from the north. What does that landscape look like? If you and I are up in a hot air balloon floating over this area east of here, is anything recognizable 2.6 million years ago? And you're like, I don't know, didn't we do that in the last show? Weren't we talking about the John Day beds and we get to the top of the Ringgold Formation and we were pretty much ready for the Ice Age? Yeah, we did. But I think I'm asking a very different kind of a question today, and I like it. I don't think much. I've been around a while. I've heard a lot of Ice Age floods lectures. I've learned a fair amount about the Missoula floods and the Ice Age floods. I don't see many people specifically talking about the before. So I'm just trying to set the hook. I'm trying to get you interested in this question, if you're not already. Here's another way to say it. And it's a grisly example, but it's the only thing I can come up with. I thought about it walking to school this morning. Let's say there's a big tornado in some small town in Illinois. And the tornado, unfortunately, comes through that little town and wipes out most of it. Total destruction. Hopefully nobody gets killed, but like whole cul-de-sacs, whole subdivisions are just gone because of the tornado. Well, you can be an AP reporter and you can type up a few paragraphs of copy and you can send that out on the AP wire. And that's one way, I guess, to talk about the destruction. But isn't maybe the most powerful way to show the damage of that natural disaster, that tornado, isn't the most effective and isn't the best way to show the damage, show a before picture and then an after picture? And you're like, okay, there's that, those are those houses, there's that street address, whatever, and then, oh my God, there's the mailbox, but there's nothing else. I think what I'm trying to do today and Sunday, we'll see how close we get, is to get a before picture before we bring in the floods. Because I think, just play along with me here, I think most of the programs on the Ice Age floods, the Missoula floods, have been focusing on the floods themselves, like during the floods are happening, and after. Here's what it looks like out in the Cheney-Palouse track. This is after the floods did all this erosion. But it seems to me that what's missing from a discussion of the Ice Age floods is the before. And just for me personally, this is a brand new set of ideas. And I've had a lot of fun getting some help by email from some geologists, reading some papers, yes, from more than 100 years ago, and just trying to work on that question. So you've heard the question. I'm trying to set up what we're doing not only today, but Sunday. Think of this as a two-part episode. It's probably solo both shows. It's solo today. There's no guest today. There's probably not going to be a guest on Sunday either. And I'm going to take my time getting us into this, but I have faith that there's a payoff. Let me try that too, and then I promise I'll get started. You're like, start with the content. This is all. We're doing a bunch of stuff. You're just not paying attention. We're doing a bunch of stuff right now. We're setting up certain questions. No. Let's go to the document camera. So you know the schedule here. This winter we're meeting every Thursday at noon and every Sunday at 9, unless there's a holiday. And we just got through Thanksgiving, and so here we are in Thursday, November 30th at noon Pacific, and we'll be back for part 2 of this discussion of pre-glacial drainages on Sunday morning, December 3rd at 9 a.m. Hope you can join us. And then eventually I'll show you the rest of December, but it's pretty much just every Thursday and every Sunday morning. Very good. There's many ways we can get into this. And that's what I was pausing about. I guess, so why 2.6? Why is that where we're trying to get this mental snapshot of pre-glacial times and what the drainages look like? Let's start with that. He goes to the document camera. Third person Thursday. Nick Zentner goes to the document camera. So I just taught Geology 101 this morning at 10 o'clock. There's only one more lecture this term. That's tomorrow morning, where we have a thrilling conclusion of Ellensburg blue agates. But let me cherry pick a few diagrams from this Geology of Washington introductory thing and at least get us started with the 2.6 business. This isn't from 101, but let me remind you from session B, where we were entertaining open questions with Jerome Lessman, who apparently is in the live stream with you right now. These are the 4 main questions that I'm working on this entire winter. Have we gotten to 1 through 3? Not really yet. We've been doing almost nothing but 4. Looking at geologists before 1922 and looking at geology that's happening before the Ice Age. Geology 101. Here's what I was taught at the University of Wisconsin in the mid-1980s. We have an ice age that's 2.6 million years of time. It's the Quaternary period. Most of the Quaternary period is something called the Pleistocene epoch. I think this winter we're going to use the words Pleistocene and Quaternary more or less interchangeably. Technically, the most recent 10,000 years of time is the Holocene, but who cares? It's Pleistocene, Quaternary, same thing. And I think almost everybody here knows that there's been oscillating warm and cold times during the last 2.6 million years. And what I was taught 45 years ago, the most current understanding in science, by the way, at the time, it's not like the University of it's not like the University of Wisconsin was a bad place to study. It was a great place to study. And I learned directly from Dave Michelson and Jim Knox and Francis Hole, a bunch of very well-respected geologists and geographers. Well, I was taught that there were 4 major cold times called glacials, the Kansan, the Nebraskan, the Illinoisan, and the Wisconsin, and then there were interglacials in between. And 18,000 years ago is the most recent cold time, and then there's been gradual warming in the last 18,000 years. Flash forward to my teaching career starting in the late 1980s, and I realized that there was a lot of marine sediment work to give us a more complete picture of the most recent 2.6 million years worth of time. And there were way more cold and warm times in the last 2.6 million years in the Quaternary or the Pleistocene. Crazy fluctuations, this pendulum going back and forth, 33 times, at least that's how I count it. Well, it depends on how you count it. My first major point is we're starting this pendulum swing at the University of Wisconsin. We started the pendulum swing 2.6 million years ago. And today, we still are starting the pendulum swing 2.6 million years ago. And why this pendulum is going back and forth, not our topic today. I don't want us to get sidetracked on astronomy and why ice ages happen. And weren't there other ice ages much earlier? Yes, there were. Hundreds of millions of years ago, there was an ice age during Pangea time and even earlier. Snowball Earth, all sorts of stuff. That's not what we're doing here. But I'm establishing that I'm asking this question about what did Eastern Washington look like 2.6 million years ago, because before 2.6 million years ago, it was not a pendulum swing. It was not the Ice Age. We didn't have these cold times when ice was coming down from Canada. We had generally a gradually steady warming climate going back to the Miocene and even earlier. Also not our topic. So this is not a global climate discussion. This is generally a nice, warm, open community, but we could have some folks who are insisting on certain things, not what we're doing. So is it clear to you why I'm asking, what did Eastern Washington look like 2.6 million years ago? That's the first time globally that we are growing glaciers, and there are dozens of times that glaciers were big globally, not just in Washington. But I'm wondering what it looks like right before 2.6 million years ago. Okay, I think I've hit that pretty hard. Well, do you have ideas? Like if we're on the, let me try it verbally and then I'll show you a couple of other things. I hope you know what we're doing. If you and I are in that hot air balloon and we're floating over Eastern Washington 2.6 million years ago, well, the freeway's not there. Okay, good. Ritzville's not there. Zips Burgers isn't there. Yeah, it's 2.6 million years ago. Got it. Is anything recognizable? How about the Columbia River? Is it there? Yes, it is. It is. Really, the Columbia River, that's a landmark? Like, is it in the right place? This is you asking now. We're having this chat maybe up in the air in the balloon. You're like, that big river down there, we're 2.6 million. You know what we're doing. Hey, Zentner, is that big river what I think it is? Yes, that's the Columbia. It's where so one day Vantage is going to be right there. That's right. So the Columbia River is fixed in the place that it should be 2.6 million years ago. That's right. And it's in a canyon. Major messages happening right now. 2.6 million years ago, we have evidence that the Columbia River is not only where it belongs, but there's a big river canyon there. And you're like, I don't think so. The Missoula floods carved the big canyons of Eastern Washington. This episode is saying no. There were already big river canyons 2.6 million years ago. Are you starting to see why I think this is an interesting question? And you're like, well, I don't think I believe that. You better show me some evidence. I will. But hint, Israel Russell in the 1890s can clearly see that the Columbia River was in a canyon many, many decades before anybody knew about plate tectonics. Pre-glacial drainages, that's the topic today. The Snake River is also in the right place. So there's two major rivers today and Sunday, the Columbia and the Snake, and they are right where they need to be. They have not moved their position in the last 2.6 million years. And yes, the Snake also has a big river canyon, but I'm going to add to it. I've got you here. I've got you here verbally. Let's just keep going. There are tributaries coming into the Columbia 2.6 million years ago. The Wenatchee River is where it needs to be. You know what I mean by that phrase, right? These are rivers that we know where they're located in Eastern Washington today after. And I'm saying most of these major rivers, the Wenatchee River, the Yakima River, Palouse River, they are where they need to be. Palouse River, not a good example. But some of the familiar rivers are where they should be 2.6 million years, and they also have canyons. Even the smaller streams and even the babbling brooks coming into the smaller streams have their own little canyons, or at least little rivulets or little dents. So I'm trying to paint a picture with words. Then we're going to look at some actual maps. Then we're going to read from Russell or some kind of combination of that. The point is, it's a mature landscape. There, that's the first time I've used this phrase. It seems like I'm screwing around, but I am doing what I want to do here today. I just feel like I need to get us into it instead of just going right to all these maps immediately. The main course of this winter, can I remind you? The main course this whole winter is following in the footsteps of J. Harlan Bretz in the 1920s. And Bretz, in those journals, in his papers from the 1920s, is talking about a mature landscape. So I know we need that concept because Bretz will be talking about it. And Bretz didn't dream up talking about these pre-glacial drainages so much. Russell was talking about the pre-glacial drainages as well. So this is worth our time, not just because it's a new set of thoughts for me, but I know it's going to pay off once we get to the main course of the series. Okay. Let me show you a couple of things that are wrong. You're like, why did I tune into this? This guy can't stay on track. So back to 101. For most of my career, this is what I have shown my students. And I have said, students, in Eastern Washington, there's all these layers of Columbia River basalt lava, and they erupted more or less 16 million years ago. And then sitting on top of all of that Columbia River basalt lava is windblown silt called loess. And I guess I have emphasized, no, I have, not just I guess. Oh yeah, let's get yellow. Don't fall in love with this, it's wrong. I have been teaching that before the Ice Age floods, in other words, before 2.6 million years ago, all of Eastern Washington is a blanket of thick loess. And so therefore, all of Eastern Washington, 2.6 million years ago, are rolling hills. So that's a nice, pleasing, simple visual. The students are writing down their notes, and it's rolling hills, like the Coulees hills we have today. The thing I've taught for 25 years in my class, until recently, is that there's rolling hills of loess from the Cascades all the way over to the Rocky Mountains. And I didn't dream this up. This is based on some rather famous scientific papers by Victor Baker, University of Arizona, and he took his leads from Bretz and others. But this is wrong. For today's topic, this is wrong. And that's why I want to talk about loess and when the loess is accumulating, and why the loess is accumulating, and where the hell is all that silt coming from. That's one of our 4 open questions this winter. And everyone, it appears, everyone in geology agrees that this loess was deposited during the Ice Age. It was deposited less than 2.6 million years ago. So if we're not getting any of this loess until the Ice Age, then I guess this diagram is saying that it was super flat. Are you following me? You're like, well, I'm taking my notes. What are you doing? I just drew that all out. Now you're saying it's wrong? That's right. I think I warned you before we looked at it. I'm caught in a bind. I've given public talks for years to farmer groups and other things. And there's always hands up at the end, and they say, excuse me, didn't you say that this loess is deposited during the Ice Age, and yet you're saying this is what it looked like before the floods? Well, are you saying all the floods happened really, really young then in the Ice Age? I'm like, well, no, there's evidence that some of the floods were older. And then they're like, gotcha. You're talking out both sides of your mouth, man. So I want to solve this. I want to redraw this somehow, or keep this drawing but change the time or something. But to say that it's rolling hills before the Ice Age, at the dawn of the Ice Age, 2.6 million years ago, is incorrect, as I currently understand it. Okay? Okay. By the way, I go on in 101 to say, well, then we bring the floods in, and we're going to make giant coulees because the Ice Age floods carefully selected certain places that they wanted to carve. And they took this innocent place and just hammered it and took the loess away and a bunch of the basalt away, leaving these giant coulees called the Grand Coulee or Moses Coulee. Well, I'm not happy with that either, based on what I've been learning in the last couple of years. I don't think we are creating these gigantic coulees from nothing. And maybe it's going to be Sunday before you totally understand what I'm saying. Can I pause? Are we doing okay? Are we 5x5 okay? And I just want to make sure that we're communicating at the most basic level. It's always a bit odd talking into this black dot, talking into this sock, and there's nobody nodding their heads out there. Bryce's head just exploded. Too busy. He's too busy selling doorstops over. Okay, good. All right, thank you. All right, that makes me feel better. We got almost 1,000 watching. All right, keep it going. So you can hopefully see that this is something I've always kind of been caught in, and that's extra motivation to ask this question today and Sunday. Okay, well, what did we do in the last show with Sky Coulee? This is my portion of what we did. This is not Sky's drawing. This is me. And saying that, yeah, we've got the Eocene sediments like the Swak Formation or the Roslyn Formation, and that's a real thing. And then there's some sort of jagged topography. And maybe, just maybe, there's a former Columbia River and a Columbia River Valley that was established before the flood basalts. Now there's a thought. If we really want to talk about a pre-glacial drainage, how about taking our buddy, the Columbia River, before 16 million years ago, carving a major Columbia River Valley with the Columbia River in it, and then totally bury the whole thing. That's even more specific than just saying there was a former rugged landscape. To me, that's worth thinking about. Now, impossible probably to say anything real, but I think almost all geologists who give this some thought agree that the Columbia River is older. They agree that the Columbia River is older than the German chocolate cake. And I think we're going to look at evidence today that the Columbia River that was flowing before the lavas was in a rugged landscape of some sort. So where exactly did that old Columbia River Valley flow? What was the trend of it? What did the tributaries going into it look like? But it was rugged, and the only reason we know it was a rugged landscape, including the Columbia River before the lavas, is that we've got varying depths at the base of the German chocolate cake, because the oil people were in here in the 1980s. Shell Oil was looking for oil and natural gas. They found a bunch in the sedimentary layers that were older than the Columbia River basalt lavas, and the depth to that base of the German chocolate cake was variable. And there were just enough drill holes to kind of get a sense that it wasn't a super flat pre lava surface. I know that's not the topic today, but it is kind of the topic that how long have we had a rugged landscape here in the Pacific Northwest? Why is it rugged? What makes a rugged topography? Well, at the end of last show, session D, we made our German chocolate cake. In other words, we made our Columbia River lavas. I think I was using red in the last sketch, right? So we bury this rugged landscape. We're good. And then you recall that in today's parlance, that's French, this is the Ringgold Formation, which is mostly sitting on top of the lavas. But we were calling them in the last show the John Day beds, to use the phrase of Israel Russell, and he had some sedimentary beds between some of these lavas. And then if we're looking at an east-west cross-section, then there's a bunch of sedimentary material coming in from the east, and that's known as the Latah Formation. And there's a bunch of sedimentary material coming in from the west, and that's the Ellensburg Formation. And we stressed in the last show that the Ringgold, the Ellensburg Formation, the Latah Formation, the John Day beds, quote unquote, we stressed that those were all younger than the Ice Age. That was the main point of the episode last time. Here we are up here at our 2.6 million years of time. But if this is all we're using from the last show, and then I ask the hot air balloon question, which is what? If you and I are in a hot air balloon looking down on Eastern Washington 2.6 million years ago, what did it look like? I guess from this sketch, we just go, well, it was flat as a pancake 2.6 million years ago. And that's also wrong. This is a long, slow buildup, but we're finally there. There's good evidence that folding and faulting and uplift has been going on in Eastern Washington for tens of millions of years. And that some of the folding and faulting and uplifting of the bedrock was happening before the lavas, before 16 million years ago. And that's why we had a rugged landscape. The general concept is if you have a bunch of lazy rivers on the surface of your area, that's fine. Those rivers are going to start digging in and making canyons if we uplift against the rivers. Uplift intensifies erosion. Don't take a cake, don't take a knife and use the knife to cut down into the cake to make your canyon, please. Modern geology says, and not modern, Israel Russell was saying this, hold your knife steady, hold your river steady, hold your drainage line steady, and lift the cake against the knife. You're still going to get a canyon. You're still going to get some sort of rugged topography, but it's the uplifting nature of the bedrock that's going to be creating the rugged landscape. So to have a completely flat landscape, if the uplift has been happening for tens of millions of years, is not the right way to think. Same idea here. To have a nice continuous rolling set of hills, if you're constantly uplifting, any sort of stream should be cutting. And that's what Russell tells us about. So I think I'm going to let the slides and Israel Russell help us. I think this is enough of the one-on-one Geology 101 teacher staring into the camera routine. There's been a half an hour of that. So let's switch it up now and use the slides and Russell himself to build on this. And I don't feel rushed this morning because we don't have a guest waiting to come on. And I'm especially free and easy this morning because we don't have to get to a certain point in the story. I'll just kind of get a sense of where we need to stop today, and we'll just continue this on Sunday. And ideally, I will hear from a number of geologists who have been watching these, and they'll feed me a bunch of new ideas that I missed or correct me or whatever. And that's a beautiful part of this series as well, that I don't even know exactly what the next letter is going to be. Okay. So let's go to the desktop. And we still have about 1,000. Hopefully we don't have, that's fine. That's great. So it's been a while since I've shown you this, and I want to make sure you know how to get to what is waiting for you. So you know how to get to nickzentner.com. It looks like this. And yeah, I'm keeping track of, I'm posting each of our former episodes here. If you have a hard time finding those former episodes in the alphabet, I'll continue to add to them here. That's kind of new. Of course, you can also see the playlist on YouTube. That's another way to do it. But, okay, let's try this. Command plus. All right. So floods and breadths. Floods and breadths. Let me show you the difference. So if you click on floods in the upper right-hand corner, you're going to see papers that are assigned to each of these letters. Can I go even more? So starting with episode C, there were 4 papers. There's 2 papers assigned to session D. That was the one with Sky Coulee. There are 2 papers assigned to today's episode, and there's 2 papers assigned for this coming Sunday. And yeah, you just click on the thing and you can get to the paper and you can read it on your iPad or your phone or your computer screen, or you can download the thing. And if you want to even go the final step, like I do, is I print them out. I like to sit under a tree or next to the fire and read them on a piece of paper. So I've got 2 more monster papers by Israel Russell, one assigned to today, published in 1899, and another one published for Sunday, 1897. And we're going to use a lot of Russell. Can I go back? Okay, very good. So you know how to get to these papers that I'm referring to. Get to the slides, boy. So the concept is this. Why can't I see? Oh, I see. I'm not on. No, I am on that. What's going on? You can't see my map of Israel Russell right now, can you? Why is this? There's the overhead. Hang on, did I screwed something up when I got nice and big. I need to figure this out. I've got some good slides for you. Hang on, I need to think. Is this in the way? I don't know how to unstick the desktop. The desktop is frozen, even though my desktop is not. Okay. I don't know how to do that. I don't want to turn the whole monitor off. Okay, maybe I'll come up with an idea as I chat, but I guess I'm going to go to the document camera and show you some things. Let's read from Israel Russell first. Let me read from Russell, and then I guess I'm going to unplug the monitor and plug it back in, see if that unsticks it. All right, so I don't know how much we'll get to Steve Rydell's paper from 2013, but that's one that's assigned to you. I am going to read to you in a few minutes from this paper, which we did talk about a couple of weeks ago. This is Israel Russell in spring of 1892. He's 39 years old, writing this elegant paper. This is another paper that we're going to read from today that was published in 1899, and these are 2 field seasons. This couple of months in 1897 and another couple of months in the summer of 1898. Russell's in his mid-40s, and he's talking about the Cascades, but there's some concepts involving today's topic that come in. And then I'm mostly going to save this one until Sunday, but this is a beauty as well, where he's down in the Walla Walla area of southeastern Washington and doing that. All right. I'm kind of half thinking about how I'm going to deal with my problem. You're not going to believe what this is, but I'll just go ahead and tell you what it is. This is our first look at the typed notes of J. Harlan Bretz. And you're like, I don't even know who that is. It's like, well, yeah, okay. There's going to be too much Bretz for you, probably, for your taste, coming soon. But these are typed notes of Bretz's as he's reading Russell. And I don't even really know the date at which he was actually writing this stuff. Like, when was he reading these papers? I mean, ideally, he's reading them and typing this when he's a high school teacher in Michigan before he even comes out, but I'm not sure. So he's talking about some notes about the glaciers that Russell's talking about, and we're not ready for the Ice Age yet. But I got a bunch of these Bretz notes. And here is Bretz writing notes to himself as he's reading a reading book by I.C. Russell, published in 1898. And Bretz is zeroing on the fact that, well, I'll just read the whole thing. We can read it together. With its wild passage through the Cascade Mountains, it is bordered by some of the most rugged river scenery to be found on the Pacific coast. A wild and exceedingly picturesque water gap, the greatest of its class on the North American continent, suggests that the course of the Columbia River is antecedent across the line of block or series of blocks upraised along the line or zone of faulting. I wanted to show you some slides about that. We'll do it in a bit. I guess let me go to plan B, which is to draw a couple things for you. So back in Bretz's time and Russell's time, these guys figured out something important. And that is that if you establish the course of the Columbia River and the Snake River, if you establish those rivers first, and then you uplift the Cascade Mountains, and you uplift the Horse Heaven Hills, and you uplift the Saddle Mountains, and you uplift, you get the point. There are these things called water gaps. And a water gap is just like it sounds. It's a place where water is flowing through a major ridge. And the biggest of all the water gaps in the Pacific Northwest is the Columbia River Gorge. Like here's Portland right here. And here's the Dalles. And here's Pasco. And here's Wallula Gap. Yeah, pre-glacial drainages. Yeah, we're before the Ice Age, and there's a huge hole in each of these ridges. The water gaps, the huge hole in these ridges is from this uplift against stream action story. It's a gradual story. Okay. Definitely improvising now because I don't have my slides, and I'm going to get bold in just a second and try to fix that monitor. But let's try this. So in this 1899 publication, which I strongly encourage you guys to read, just in general, like Backcountry Gary, you're here today. This guy's over in Darrington. He's up at Monte Cristo. Gary, do you know about this paper? I mean, this is incredible stuff by this guy, Russell. But here, let's go to the golden box. Look at this amazing map that's more than 120 years old. And I can't light it very well. And if I can get the slides to work, we can look at it a little bit more carefully. But I'm trying to point out to you now, my God, I'm working up a sweat, is that there's a certain pattern to these drainages. This is something known as a dendritic pattern. This is a dendritic drainage pattern. And I think I need to explain that the best I can without slides, and then I'll get to the slides. But you'll notice that we don't have major dendritic patterns, at least on Russell's map in 1899. So I made some notes specifically for you and me and not my 101 class. That's how much I love you. Here's the notes for today's lecture, by the way. So we did that. We did that. And now we're working on this. A mature landscape with major river canyons and ridges are a thing before 2.6 million years ago. I should put our hot air balloon up in here. This is you and me. Oh, God. That's a hot air balloon, everybody. So the word dendritic, these are just notes to myself. I wasn't planning on showing them to you, but I don't have the slides right now, so we'll tie this instead. So if you look up dendritic, it means having a branched form resembling a tree. And here's a tree, everybody. That's a person. That's a trunk of a tree. And if you get up into the branches, you've got smaller branches, and then each of those branches has smaller branches, and then each of those smaller branches have little twigs coming out. Good. Well, here is the main message of today. One of the main messages of today. What evidence do we have on the surface of Eastern Washington today that tells you this is a certain part of Eastern Washington that never got hit by the Ice Age floods, and instead is the result of the bedrock lifting and in some cases even knuckling up and forming a ridge? In other words, are there drainages in Eastern Washington that show evidence of a slow and steady uplift of the bedrock against the streams and rivers of varying sizes? And the answer is yes. It's the dendritic patterns that tell you there's not a catastrophic story there. This is the main message of today. I'm trying to do it verbally, looking into your eyes, and then we'll try it again with the notes. One more time. Dendritic, develop an eye for it, because the dendritic area is saying this is not a place throttled by the Ice Age floods. Instead, this is a normal, quote unquote, normal signature of gradual uplift against intensified streams and rivers. So looking down from heaven, we can draw a line, and that's a drainage divide. We can literally walk that ridge if you want. And in certain places, if I can get the slides to work, I'll show you some places where we have those drainage divides, but it's not some steep arete that you got to worry about falling off. It's maybe a rather subtle ridge top. But look at our drainages. And I just drew these freehand. Do I really need to do this? I don't know. I just feel better doing it, I guess. Like a tree, the dinkiest babbling brooks feed into the next bigger stream. The next bigger stream, we all know this, don't we? The next bigger stream feeds in, gets bigger and bigger, and we eventually have something called a trunk valley. It's a master stream, a master river, all this sort of thing. And the same thing going the other way. What I'm trying to say is this is only possible if you're uplifting the land and this ridge is knuckling up. The other thing I'm going to do, since this is my chalkboard for today, is why is the knuckling up happening? Do you have an answer? Why is this bedrock in the Pacific Northwest lifting so dramatically? And you're telling me some of the uplift has been happening for tens of millions of years? Yes, I am. Red Lester's got it. Sauber's got it. A bunch of you have got it. This is from class this fall. I'll do this quickly. This is Yellowstone. These are in purple, the line of supervolcano calderas that go back further and further in time. The Yellowstone hotspot used to be at each of these locations. Why? Is it because the Yellowstone hotspot has been moving like this? No, it's because the North American plate has been drifting over a stationary mantle plume. Yes, I choose to teach that not all geologists agree with this, but many see that the Silesia large igneous province out there in the Pacific Ocean was fueled by the Yellowstone hotspot 55 million years ago. What am I getting at? This line of supervolcanoes is no longer a line. Once you get into northern Nevada and northern California, those calderas aren't there anymore. They exist, but they're not there anymore. They're not lined up like they used to be. What happened to them? They got moved. Like, what are you doing? I thought you were just going to tell us why things are knuckling up in Walla Walla, Washington, or Othello, Washington, or Yakima, Washington. What are you doing? I'm giving you the answer. The answer is there's clockwise rotation of the Pacific Northwest crust. Ray Wells and others say there is 1 degree of rotation every 1 million years. And that this rotation of the crust around Pendleton, Oregon, has been going on for 50 million years. Like you accrete Silesia 50 million years ago, and you start the clockwise rotation. And as you can see, these arrows being longer in the west than they are in the east, because the pivot point is Pendleton, Oregon. Some say Orofino, Oregon. That's what Basil Tikoff says, whatever. You have less and less rotation towards Idaho. You have more and more rotation as you get out to the coast. And what's this got to have to do with the price of tea in China? Those are the ridges of something called the Yakima Fold Belt. And the reason these ridges exist is because there's no rotation in Canada or northern Washington. And you're like, why not? If you're so in love with this fact that the clockwise rotation is fueling this uplift and causing these pre-glacial drainage patterns, this dendritic stuff, if you're so in love with that, why are we compressing and uplifting at all if everything's rotating? Well, it's not. Canada and northern Washington are not rotating. So you're rotating things 1 degree every million years, and you're taking Northern California and getting closer and closer to Canada every year, and we're squeezing and cracking and folding this rock and tectonically lifting the bedrock of central Washington. And you're like, why isn't there rotation happening up here? We don't even need to do live Q&A. I'm doing live Q&A to myself. We think the answer is the Juan de Fuca plate is doing that, and the Pacific plate is doing that. And those two motions, this northeastward motion of the Juan de Fuca plate and northwestward motion of the Pacific plate, is driving this clockwise rotation. And by the time you get to the northern edge of this piece of paper, there is no oceanic plate doing that. So this clockwise rotation is happening due inland of these two ocean plates doing their thing. This is a scramble drill. So I got to get these slides to work. Give me another second. We're still frozen because that's not what it looks like. So I hope we stay together. I'm going to unplug the monitor and plug it back in and see if that works. Okay. Drum roll, please. Damn it. Okay, we're still frozen. Okay, I don't think we're going to have slides today. And so we're going to save the slides till Sunday. I want to thank some people who have been generous since the last show. And I'm looking for more help. Sky Coulees says, switch home screen off of whatever's on the second I can't obsess about it. The second monitor is just totally frozen, and I think it's got to do with OBS, but I don't want to screw that because we're going to lose our connection. Okay, so hang with me. We're going to do some live Q&A in just a second. God, what do I want to do? Yes. This is one of those shows where while you're doing it, you're like, this is a complete disaster. And then afterwards, you watch the replay, and you're like, yeah, it was okay. You weren't feeling great, but it was okay. People hung in there. So we still have a document camera that works. So I just read these notes to you. That's what got us into the Yakima Fold Belt and that sort of thing, this water gap thing. And here's Brett's taking a few notes from the Cascade paper that has been assigned to you today. And this is what, out of that whole paper, here's 3 sentences that Brett's made notes to himself. The Columbia lavas rise from the plains to the summit of the Cascades with a gradual slope of 4 degrees or so. This is in the latitude of the Yakima River. So Russell, without saying it specifically, likes the idea that there was a plateau across what is now the Cascades. And I think he's kind of hinting at, he wonders if the German chocolate cake once continued all the way across to Western Washington. And I've only heard one geologist say that out loud seriously, and that's Eric Cheney from the University of Washington. Has that thought ever occurred to you? Yeah, it's something called a peneplain, where Russell and even Brett's are taking notes on the idea that there's a bunch of plateauish-like surfaces that they can squint and see some sort of continuous plateau through the Cascades from eastern Washington over to western Washington. And there's been so much uplift and erosion of that former flat surface known as a peneplain that they think they can see that older surface. And the part that I think possibly Russell was hinting at is that the Columbia River salts once crossed the Cascades when the Cascades were lower. Doesn't seem like there's a ton of evidence for that, but it's always been an idea that's appealed to me. I think it's fascinating that Brett's is taking certain specific notes from certain papers. And so I'm finally to what I wanted to say here. Russell, a Rivers book. So I mentioned in the last show, I think, or maybe 2 shows ago, that Israel Russell, in addition to doing this exploring and writing these scientific papers that we are reading together, Russell also decided to write some books for the general public with titles like Lakes of North America as a book, Rivers of North America as a book, Glaciers of North America as a book. And did you notice what's leaning against the Z in the bookshelf? There's a 3rd reading book that I now own, thanks to one of the viewers who said, I think you need another Russell book that you don't have, and somehow found online a rare book by Russell and sent it to me. And so Victor from Carmichael, California, thank you for purchasing and sending quickly my new edition, or my new book to add to my Israel Russell collection. So I now have 3 old Russell books, and it's the Lakes of North America that Victor purchased and sent my way. It's the Rivers book that Brett's is taking his notes from. So even though these are books for the general reader, and I think Russell referred to these just as humbly just reading books, there is $18.95. Thank you, Vic. Let's read a little bit of Russell together, and I'm going to read directly to you as I look into your eyes. It's a couple passages from 2 of the Russell papers that I wanted to share with you. And then I'm not sure what else I can do with you without those slides, but maybe I'll pause one more time, see if I can fix it. Okay, my pages are all out of whack because I've been panicking. Hang on a second. So let's read a little bit from Russell, 1899. This is his Cascades paper. Let's read this first part together. The region referred to in the above title embraces attractive country about 60 miles wide. I only did reconnaissance in the area back in 1892. I came back for 2 field seasons in 1897 and 1898. This is Israel Russell we're talking about. The work I did during this stretch the last 2 years was under the direction of Mr. Bailey Willis. Willis is going to come back to us in the next couple of letters. I started in 1897 on July 5th in Coulees, Washington, at a railroad station in the Northern Pacific Railroad, and I ended my summer's work at the same Coulees station September 22nd. Detailed geologic work has since been done by Mr. George Otis Smith. I don't think we'll do much with Smith, but he's also a heavy hitter in this game. He's got one paragraph that's, no, let's do it this way. Russell, if we go back farther still than the Ice Age and study the great valleys that have been excavated in the Cascade Plateau, for the plateau it really is, in spite of its rugged aspect, we shall find that the valleys on the west side are deeper and show a more advanced stage of development than those on the east side. These valleys had about their present depths previous to the birth of the old glaciers, and as I hope to show later, owe their main difference to the contrast in the climate conditions to which they were subjected previous to the glacial epoch. Now, you can do this reading as well as I, but I'm grabbing areas, I'm grabbing paragraphs where he's wrestling with this idea that we definitely have canyons carved by rivers before we get into the Ice Age. And that's the whole point of this episode and Sunday's episode as well. Full disclosure, I've gotten a bunch of beautiful imagery, maps, LiDAR imagery from both Sky Coulee and Joel Gombiner, who some of you know from field videos in the last couple of years. Those guys are gifted with imagery, and they've been feeding me by email a bunch of images. I'm kind of relieved I don't have all those queued up for today because I wouldn't be able to show them to you, but I'll have things ready to go by Sunday. In the northern half of the Cascades, the streams flowing eastward are separated from those flowing westward by a divide or watershed, which follows a generally north-south direction. These opposite flowing streams head against each other and have extended their headwaters until the divide between them has become an irregular sharp crest ridge. Every main stream has numerous branches, and all portions of the uplift are well drained, except where lakes exist. And these, as will be shown later, are due principally to obstructions left by glaciers in previously stream-eroded valleys. Now, I want to remind you that I'm reading a lot of Russell, and he's getting into all sorts of Ice Age stuff. I know that's there. I know he's talking about Lake Lewis. I know he's talking about alpine ice coming down the Wenatchee Valley and all sorts of things. But I'm not ready to do that. I'm not focusing on the Ice Age stuff that Israel Russell is talking about. He was clearly an influence on J. Harlan Bretz in that regard as well, but I'm just selecting places in the Russell papers that are talking about pre-Ice Age, as is the topic today. My papers are totally screwed up now, but I want to continue. I'm going to read this one to you this way. He's got something, actually, the title of this section is called Mature Topography, and that's the dendritic thing we're talking about. What a mess. Reasons for the differences in the amount of work performed by these opposite flowing streams are not difficult to find. Now he's talking about the Cascades and talking about basically a divide coming right down the crest of the Cascade Mountains. Just like I was showing you. God, I need to find that. Hang on. Hang on, Patrick. Damn it. Can't find it. The one where I had the divide on the map and then I had the dendritic stuff going away from each other. Russell's thinking about the entire Cascades as a big divide and then talking about the rivers flowing east to the Columbia and west to Puget Sound. Reasons for the difference in the amount of work performed by these opposite flowing streams away from the crest of the Cascades are not difficult to find. The streams flowing westward discharge directly into the arm of the sea, Puget Sound, while those flowing eastward join the Columbia, the master stream of all the eastern portion of Washington, at a considerable elevation above sea level. Or to use more technical language, above base level of erosion. This is Israel Russell in the 1890s. At the present time, the dense vegetation on the western slope of the mountains retards mechanical erosion, although favoring rock decay in solution, while the east side of the slopes are generally much more freely exposed to the infrequent rains and more readily erodible. It does not seem probable, however, that the differences in the forests were so marked in the late tertiary time. So Russell's wondering about when did the rain shadow effect begin? And during much of Ringgold time or John Day Bed's time, was there much of a rain shadow at all? And were we heavily forested in eastern Washington, at least a portion of it, with those drainages? If you look at the map, says Russell, it will show that the streams have reached a stage in their development that may be designated maturity. The smaller creeks and the multitude of brooks and rills tributary to the larger streams are not shown, but even in their absence, it is manifest that all portions of the region are well drained. In the region under consideration, the principal streams flowing eastward from the main Cascade Divide are, in their order from south to north, the Yakima River, the Wenatchee River, the Stehekin, the Chelan, Methow, and Similkameen. Each of these rivers has its source close to the main divide and its tributary to the Columbia. The streams on the west side of the Cascades furnish even stronger evidence of maturity than those on the east. The waters of hundreds of brooks and creeks there unite to form rapid, but not impetuous, rivers while discharge into Puget Sound. The features just referred to will be recognized at once by geographers as evidence of well-developed drainage. The main streams have reached maturity, except near their sources, and have comparatively low gradients throughout. I may be losing some of you. We still got more than 900, but we're going to do one more thing together, and then we're going to do some live Q&A. Now he's in Eastern Washington. In some instances, the secondary folds and faults referred to originated after the initiation of the present system of drainage. The Columbia crosses Saddle Mountain by means of a sharp-cut water gap, and the Yakima River flows through narrow gaps in the same character at several localities. Evidently the right-of-way, so to speak, of the Columbia, and of its several larger branches from the west, was determined before the rocks over which these streams flow were broken and blocks thus formed vigorously tilted. More than this, The tilting of the blocks or the growth of the faults bordering them must have gone on so slowly that the larger streams were able to maintain their previously established courses and were not turned aside. This is a significant fact in reference to the date of the elevation of the old peneplain, which gave the Cascade Plateau its general uniform level. Okay, I got a couple things to lob out there. Ask for help, and then we'll turn it over to live Q&A. First off, I don't know why peneplains are out of fashion. I mean, I was taught by some old timers back in the 1980s at the University of Wisconsin. They were still teaching about peneplains, but most everybody doesn't use the term peneplain anymore. Is peneplain a concept that is from pre-plate tectonics days? And is that why people don't talk about peneplains anymore? I mean, all I understand is that a peneplain is a former plain that is now mostly gone. And it's usually talking about mountainous areas. I'm attracted to the concept that you can take these, what appear to be individual little flat benches, and say, oh, look, they're all part of the same thing. It's just mostly gone. I mean, I like that. That's pleasing to me. But I don't know why peneplains are considered out of date. I was going to say one other thing there. Yeah. I'm going to switch to a little bit of help that I'm going to ask of you before Sunday for those that have the time and the interest. And again, I wanted to set all this up with the slides, but I just don't have the slides today. So this is going to come from out of the blue, but I'm going to ask it because I need a little help, ideally before Sunday. And by the way, when I've asked for help in past episodes, some of you are so on the ball that by the time I say goodbye, thanks for joining us, there's like 5 emails with all sorts of answers. So some of you are like ready to go. J. Harlan Bretz was a high school science teacher in Flint, Michigan. It was his first teaching job out of college. Can I ask some of you for help? Can you show me proof exactly the years that Bretz was teaching high school in Flint, Michigan? Now, I know he taught high school in Seattle. That's not what I'm asking about. That's a little bit later. There's a little bit of inconsistency between the dates that I have from John Sonickson's book, and I emailed John. I haven't heard back from him in the last couple of days. And I want to finish Sunday with a very specific moment in time. And so I need some help double checking some dates. So I think Bretz taught high school in Flint, Michigan for 2 years. Was that between fall of 1906 and he left in the spring of 1908? Or the fall of 1905, and he left in the spring of 1907. You're like, who cares? There's a reason. There's a reason. It involves meeting Russell. And there's a small chance he never met Russell. I really want it to be true. I've got good evidence that he did meet Russell in his home, but the dates aren't adding up because I know when Russell dies. Same ballpark. Can you confirm the date that J. Harlan Bretz got married to his college sweetheart, Fanny? Harley met Fanny when they were both students at Albion College in Michigan. I believe they both graduated in May of 1905. But I think they got married in the summer of 1906, but maybe 1905. That would be helpful as well. And they're like, what are you doing? I want to remind you that we are learning from each other this winter, and I'm packaging a bunch of information for these downtown lectures in April. And there's a few spots here and there where I need some help. Speaking of help, I have to do it verbally, and then I'll show you on Sunday. Jason in Muskegon, Michigan said, I went to the university. Jason in Muskegon, Michigan said, I'm a graduate from the University of Michigan in Ann Arbor. I still live pretty close to Ann Arbor. I'm happy to drive in to campus and find some of the Israel Russell documents and photos that his family donated. And he did. And Jason took some photos. So I have some new photos of Israel Russell, in thanks to many of you who emailed me a few of the photos that are online. But Jason found some more good stuff that are literally Russell's photos that I crack it open with the gloves on and nobody's looked in that manila envelope for 80 years or whatever. So thank you to Jason. I'm excited to share what you found for us on Sunday. Let's do some live Q&A, and maybe at the very end, we'll see if this can, if I can fix my problem. But otherwise, that was scattered, but maybe there's stuff that you want to talk about. And this also helps me gauge what you might want to learn more about on Sunday. If you got to run, I understand. We still have 915 watching. Uppercase for your question, please. Let's just try a few things. Let's try it one more time. Still frozen. Wait, I got an idea. Hang on. I got an idea. That. Double click. Oh, I think I've got it. Hang on. Click away. Click back. I got it. Hey, everybody, just kidding. We're not doing, you can see this, right? Yep, we're in business. Thank you for your patience. I'm glad that you're still here. I had to do a trick within OBS that Nat Nickel taught me a bunch, but I finally remembered to do it. So you're still here. We still have 914. We lost one person. Let's look at some slides. I will thank Jason one more time, and then we'll go to your live questions and answers. Okay, great. Thank you. I feel so much better that this appears to be working now. Okay, so disjointed as it was, perhaps there's some messages that went into your homes. Here's Ellensburg, and we can see our dendritic patterns. So, for instance, right in here, from our lesson today, there's dendritic draining east, there's dendritic draining west, so there must be a divide right in here. And that also must mean that this area never got screwed up by the floods. That's all correct. This is the photo that we have all been staring at for the last couple of shows. And Russell dies at the age of 53. And so perhaps this is a portrait taken of Israel Russell within a year or two of his death. He died of pneumonia, but I'm giving away Sunday's story, which I don't want to do. A number of you emailed me this photograph, which is a new photograph for us. No context, but again, I didn't take everybody's name down. I'm getting a couple of hundred emails every day. I hope you're okay. You help me out. We help all of us out. In most situations, I can't say your name or keep track of, because I think 7 people emailed me this photo over the span of 3 days. So all I can just say is thank you for helping, and we'll just enjoy your efforts. Here's Jason with his protective glove. And you're like, wait a minute, that's the same photo, isn't it? Yeah, probably is. But this is like the original. This is like Israel's wife or Israel had this personal photo. And so this is Jason deciding he's going to drive into the Bentley Historical Library, I think the day before Thanksgiving or something. So again, thank you, Jason, for your generosity. If you happen to be here, please take a bow in the live chat. So this is a high quality version that I think Jason scanned at the library, or maybe just snapped with his iPhone. There's a bunch of books there that Mrs. Israel Russell gave to University of Michigan. So Israel had his own little, I don't know. Many of us are familiar with this photograph. I've been looking so carefully at these photographs now. I'm pretty sure this isn't him. This is a handsome dude, but I don't think that's him. I think that's Russell, even though he's identified as such on certain websites. I think this is our man. I think that's Israel. It's kind of a sad-looking guy, generally. And this is 1891, I believe, when he's up in Alaska. Photos that can be found online, but also from Jason's trip to the personal archives of Israel Russell. So USGS survey, this says on the left, and Israel's sitting front and center. So again, half the time I don't mean to say it this way, but I often wonder if the date's right and if the people identified are correct. And I was like, how would we know? Like Salt Lake City, Utah, 1882, that's probably right. Well, here's Israel's actual photograph. And he's like at the Salt Lake office, 1883. So I guess I'm going to take Israel's word for it in his handwriting with his little pencil below his little scrapbook. But so this is Israel in his late 30s, early 40s. Another photo. I can't remember if this is Jason or if this is a couple of you emailing it. By all accounts, and we're going to read some of the obituaries on Sunday, by all accounts, a soft-spoken guy, kind of a frail look to him, but as tough as they come. Now, here's more homework if anybody's interested. These are from Israel Russell's collection, but I'm pretty sure Israel's not in this photo. He's numbering the people here. This is Israel saying, I think this says Lahontan, so it's like Lake Lahontan in Nevada. Lahontan Sediments, Walker River Canyon, Nevada. Can anybody figure out who these people are? I don't know how helpful it is to us, to our series. Another shot from that scrapbook. Pretty sure Israel's not in this photo, but I guess there's a chance he is. And I think the same cast of characters, more or less. But if we're back in the 1870s with the Wheeler Party or something like that, I have no idea. Just curious. Might be Bailey Willis now that I look at that hat. He looked kind of like, well. So this is all Jason helping us here. And these are originals from Israel Russell. He did some fine work down in California with Mono craters. He did some fine work in the Mono Basin, a moraine at the mouth of Lundy Canyon. I forgot about my bubble blocking the date. This is the spring of 1892, just reminding you that the red lines are where Israel and his assistant Samuel went in the spring of 1892. And to me, one of the most memorable moments of this entire winter so far is Israel up here at Calacum Pass looking east, looking down on the Great Northern Railroad being built and writing that beautiful prose. This is all from the spring of 1892. Just enjoying some old photos. This is not from Jason now. This is just me taking the photos directly out of the paper that's been assigned. Is there Ice Age flood stories here with the gravel terrace? Absolutely, but we're holding off on the Russell Ice Age stuff. I was just up filming a new Nick on the Rocks episode here with Brady in October. Still 1892. Russell and Sam are now down in the lower Yakima Valley. One photo from that. Here's Sam looking at the Simcoe landslide. Not a very good scan. In fact, that whole Walla Walla country paper, the scan that I have for you for Sunday's show, is of poor quality. I'm not sure what's up with that, but the map is wonderful. And again, this is a sneak peek for Sunday, but Israel's tromping around in the fall of 1896 down by Walla Walla, Washington. I just can't get enough of these old maps and these old photos. If this bores you, I'm sorry. We're ignoring the ice that Israel's talking about. God, I really forgot about my bubble here. Sorry. This is the summer of 1897 and 1898. And again, where Russell is getting on foot or horseback. This is the summer of 1897 at a place called Ingalls Lake and Mount Stewart. Here are my kids in the summer of 2009. 1897, 2009. 1897, 2009. I'll save the gravel stuff. Okay, this is what I really wanted to get to. We still have almost 1,000 people watching. And I know many of you in replay maybe gave up a while back, or maybe you skipped ahead to this because it looked like the slides were working. So good job by you for scrubbing through the middle of the show where I was scrambling. It's these Yakima fold belt slides that I think are going to work much better, perhaps, than what I was doing with my Sharpie pens. So let's hit this hard. And I've got some questions for you, just open questions. Here's Ellensburg. These yellow blotches are cities today. Yakima, Tri-Cities. Here's Wallula Gap. Here's Walla Walla. Here's Spokane. Here's Seattle. Good. I don't know who made this image, maybe Terry Tolan, but I've used the hell out of it for the last 25 years. I think it's outstanding. The main reason is it shows the ridges. And if you missed it, these ridges were essentially built by 2.6 million years ago. I don't think I got there very carefully when I was talking about the hot air balloon with you. But not only were you looking down at the Columbia River and the Snake River in these big river canyons, you and I, and the balloon 2.6 million years ago, the Saddle Mountains and these other ridges are nice and tall. They're not as tall as today, but they're maybe 3/4 of the way up. And I have confirmation from a few geologists who I really trust that those ridges are recognizable, and they've gotten themselves established almost to the point where we can see them today. Why is that such a big deal? Here's why I think it's a big deal. Why? Big moment. It involves the Ice Age floods. Why are there so many big coulees in the western half of the Columbia Basin and not the eastern half? I mean, the Ice Age floods hit all these areas across the Columbia Plateau, the channeled scablands. That's what I'm talking about. But it's a pretty recent question I've asked myself, why are those coulees only in the west and not the east? And I had Jerome Lessman in my ear, literally, and then also by email, wondering, well, maybe that's because, let's go back to the map, maybe that's because there's an undersold story of major ice age floods coming down from the Okanagan and cutting these coulees over here. And maybe the reason there's not major ice age flood coulees in eastern Washington is because there's not Okanagan-like floods coming down. Well, I think I have a different answer right now. I'm not sure of it, but I'm wondering, as we lose the folds, because these folds, these Yakima folds, this uplift, in other words, gradually dies as we go eastward toward Walla Walla, toward Lewiston. The Yakima fold wimps out as you go east. Is that a major reason why we don't have major coulees over here? What I'm trying to say is, if you have a major coulee in eastern Washington, can you assume that before the coulee is cut, there was a major river valley there? And taking it a step further, if there's a major river valley there, is that because you need a ridge lifting against the river to make the valley? Are the major coulees of eastern Washington in the same places that we had major river valleys pre 2.6 million years ago? And is the answer for why those major river valleys are where they are is because that's where the uplift has been most intense. Ultimately, coming back to the clockwise rotation, because we're pivoting the whole story here, and the rotation is way more extreme or way faster out here than it is back here. Calm down. So yeah, if you're west of Othello, Washington, you do that. And you don't just do that, but you incise the rivers, you entrench the rivers. And so look at this thing, man. Here's the Columbia. Here's the Yakima. I'm less confident about the Snake. I guess there aren't major uplifts across the Snake. Maybe there are. I don't know. But to me, that's a getting back to the tease at the beginning of this episode, before I realized I had trouble with the slides. I was trying to convince you that it was worth contemplating where these pre-glacial valleys and canyons were. Maybe you're starting to see why it's an interesting question. And a few of you might be going, yeah, I had this figured out like 20 years ago. Where have you been? Thinking about other stuff, I guess. These are new thoughts to me. Finish the slides, boy. I say, finish the slides. Yeah, do we know this clockwise rotation is a thing now? Of course we do. We have red dots, which are GPS receivers that are monitored by people up on the third floor of this building. Yes, we know that those stations are moving. Every year they're moving. But they're moving at different vectors, different speeds, and collectively they are the clockwise rotation. And I'm saying, if we don't have a ton of clockwise rotation in here, there's no reason for us to be forming ridges or to having these rivers cut so deeply and forming a dendritic stream pattern. Why is the clockwise rotation happening? Bob Butler, University of Portland, says, let's make an animation and show you. The Pacific Plate and the Juan de Fuca Plate are actively driving the leading edge of the North American Plate in a clockwise sense, making individual microplates within the westward moving North American Plate. And so there we go. All these seismic stories, shallow crustal faults like the Seattle Fault and the Tacoma Fault, they appear to come all the way through to eastern Washington. But why are we talking about earthquakes today? We're not. That's what the yellow dots are. They're earthquakes. We're not talking about earthquakes today. But we are talking about the pattern of where we find these folds and these faults and the fact that this is a pre-glacial story that continues through the Ice Age and continues right now. Joel Gombiner, during the pandemic, bored out of his mind and making custom maps for me. He didn't have to do that. I don't think I even paid him anything, Joel. Thank you. Gorgeous. Saddle Mountains, Frenchman Hills, Badger Mountain Anticline, Menashtash Ridge turns into Umtanum Ridge, Autanum Ridge, Rattlesnake Mountain. Am I getting screwed up? Rattlesnake down here. Toppenish Ridge, Horseheaven Hills, Columbia Hills Anticline. These are the things we're talking about that have entrenched these rivers. Joel Gombiner. Holy cow. We're going to use these a lot. Oh, I think I see the floods here. I think evidence of the floods. Yeah, no kidding. Yes. But we're realizing that the floods didn't create much of this. If we know how to look for dendritic stream patterns, we know we're high and dry from the Missoula flood story. Good God, Joel. All right, we're going to save this. So we got to some of the slides. Thank you to Jason. Thank you to Vic for the book. Thank you to many of you for helping by email. And I look forward to some of the additional help that some of you will provide over the next couple of days. Before I lose my train of thought and we turn it over to live question and answer, Sunday will be specifically reading Russell's stuff from southeastern Washington. But Sunday will also be, I think, going to individual places like Moses Coulee and looking for evidence that Moses Coulee was not carved from scratch, but that there was a pre-glacial drainage there. Now that we kind of know what we're looking for, we can piece that story together. I'm pausing because I'm still trying to wonder if I should go further. I should not go further. Uppercase for some questions. Let's keep it fast-paced before we quit. Wasn't there a photobomb guy out there? I didn't recognize who that was. I don't think he was a student. I wonder why Crab Creek exists all the way from Rock Island to Spokane Airway Heights. Crab Creek is a very long drainage for sure. It's worth thinking about. I don't know. Cynthia, where was the coastline at this time? I am curious how the sea levels due to glaciers affected the coastline topography and the floodwaters as it moved west down the Columbia. Thank you, Cynthia. We will have Joel Gombiner on at least once, and he wants to talk about the Astoria fan and all that's out there in the water of the Pacific Ocean. And folded into that show, I'm sure, Cynthia, will be talk of sea level and where the coastline was. So let's wait on that one. Will, where were the rivers before the German chocolate cake? Great question. Don't know. I showed a quick map from Joseph McMacken in 1937 in the previous show where he guessed as to where the Columbia River was and then the side valleys coming in. But I don't know if we can do any more than guess. Jim, how much water is there for the Columbia to do erosion during the Ice Age when so much water is locked up in the world's ice sheets? That's a question for the ice sheet, I think, Jim. It's a good point, but I want to focus on pre-Ice Age today. Trevor's asking about Lake Missoula. I appreciate your enthusiasm, but we're staying disciplined, boy. We're staying disciplined to pre-Ice Age discussions here. Kirk, wind gap / river gap are all the same? Is there one on Saddle Mountains to the east of Beverly? Thank you, Kirk. Water gaps are where the rivers are currently flowing through a ridge, like Sentinel Gap. Wind gaps are stupid names because it sounds like the gap in the ridge, if it's a wind gap, was carved by wind, and it wasn't. Nobody's saying that. Wind gaps are former water gaps where the river finally said, screw it, I don't want to cross here anymore. This ridge is lifting too high, and I'm going to go someplace else. And so was Saddle Mountains crossed by the Columbia or some other river in an earlier time? And then the Saddle Mountains grew so fast that they took that former water gap and make it a wind gap? Yes. I have a vague recollection of Sky Coulee talking about 2 or 3 wind gaps along the crest of Saddle Mountains. Maybe the saddle of Saddle Mountains itself is a wind gap. Thank you. Down to live. We're praying. Okay. Did the CWR uplift the Cascades, creating the rain shadows? I don't know, Saber. If Sky's still with us, he's got thoughts about the rain shadow. I don't know. I'll defer to him on that. You guys talking about Glacier Lake, Missoula? Appreciate it, but I don't want to do that now. Zoltan from Europe. Were there lakes north of the ridges? Interesting question. I'll take the spirit of your question. If we're pre-2.6 million, were there lakes? I think what you're asking is, do ridges screw up drainages, and do you have lakes then next to a ridge because the river can't flow anymore? I think what I'm saying is, I'm not totally confident in this answer, by the way. Thank you for the very interesting question. Generally, in my 101 brain, if the river's there and the ridge is growing, then we're not going to form a lake because the river just maintains its pathway through the ridge. We've got no problem. But if we're quite a ways older than the ridge forming nice and big, then we're back in Ringgold time, and Sky Coulee's got his Lake Ringgold, or Lydia Steisch has their Lake Ringgold, and there were ridges about the times that the ridges were there. Generally, I'll make one more general statement. There's a ton of lakes between Ritzville and Spokane. I'm confident that none of those lakes were there before the Ice Age, that those lakes are a direct result of the Ice Age floods. Papagino, I think I did define the time frame. The most recent 2.6 million years is the Ice Age that I'm referring to, with dozens of cold and warm times within the Ice Age. Brandon, do we have any idea for when Grand Coulee started forming? Well, that seems like a simple question, Brandon, but it's complicated. Because if you're saying there's different ways to answer that question, I might use that on Sunday, Brandon. I'll try now, though. Well, I'll workshop it right now. You might go, how old is Grand Coulee? And then you would say, well, can you clarify that question? And they're like, no, how old's Grand Coulee? And they say, you need to clarify it. Grand Coulee like this, younger than 2.6 million years. But before Grand Coulee was like this, Grand Coulee was like this. And if you're asking about that, we're going back 15 million years. And even before the Columbia River basalt lavas, I think there were things like that got totally buried by the lavas. Rob's basically saying stop. He's saying leave them wanting more. I kind of agree with you. Basic rule of showbiz. 3 more and we're done. I'm way back. No, I've already answered those. Now I'm down to live. Daryl, could landslides help cutting the valleys? Yes, for sure. I don't know how much of a contribution it is for our concepts today, however. David, why is the Columbia Plateau tilted to the west? You got to tune in on Sunday for that. Thank you. If that's part of the science papers assigned for Sunday. John, if pre-Ice Age lakes, could they have released and caused earlier floods? Thank you, John. Well, if you have a lake 4 million years ago and you release that water somehow, could it cause an earlier flood like before the Ice Age? Yeah, I guess it could. But I don't know if we have any evidence of that within the Ringgold Formation, let's say. We're just, ultimately what we're doing. We're setting the stage for releasing the fire hoses and sending this Ice Age flood water in. And that's how we will finish. That's how we will finish. We'll go back to the beginning. If I can find those two diagrams, that's how we'll finish. Found this one. So one of the main messages from today is that if you have gradual uplift due to the clockwise rotation of the Pacific Northwest crust and you deform these divides that knuckle up, you're going to start movement of the water gradually. Even these tiny little babbling brooks are going to carve a little bit of a canyon, baby little canyon, and we're eventually going to gradually drain this. And the concept is every drop of water in precipitation is going to be drained to the ocean because of this perfect setup, this dendritic setup that just is ideally developed over the course of millions of years. And that concept of dendritic pre-glacial drainages does not work with this message and does not work with this message. And that is the main contribution from today. A toast to you. Thank you for joining us today for episode E entitled Pre-Glacial Drainages. Here's to your health, wherever you happen to be viewing live or in replay around the world. If you were brand new to us and had never watched live before, and you're still with us 2 hours later, I applaud your patience and dedication. Whether you're sitting staring at the screen or cooking a beef stew or whatever you do during these shows, I realize it's not fast-paced, but when I don't have a guest, I like being slow and careful. So that's a toast to me, I guess. I'll see many of you, I hope, this coming Sunday, December Take two. I'll see many of you on Sunday, December 3rd, 2023 at 9 a.m. Pacific time. Title of episode F, More Pre-Glacial Drainages, unless I come up with something better. Thanks, everybody. Have a good night. Maybe some of you will go to the Ware Fair, the Student Union building over at Central, and check the beginning of this live stream for details if you're interested. Thank you. I love you, and goodbye from Ellensburg, Washington, USA. Goodbye.